Hello my dear students, this is MathDOC. So during this session, I mainly focus on vertical asymptote of a function. Vertical asymptote of a function. So vertical asymptote, it is an imaginary line, in imaginary vertical lines. So to identify a vertical asymptote, you need to check denominator zeros. You need to check denominator zeros. So these are rational function types. These are rational functions type. So if we have rational functions with denominator zeros, then definitely that contain vertical asymptote. Vertical asymptote. So first step, this is a rational function. You factorize denominator completely. Factorize denominator completely. So thereafter, cancel common factors in both the numerator and denominator. If we have common factors, cancel it. Then finally you analyze denominator zeros. Then those denominator zeros we call vertical asymptotes. Vertical asymptotes. Let's see. So this is y equal 1 over x minus 1. So we have one factor in denominator, then that is x equal 1. We say x equal 1 is a vertical asymptote. So here we have two different factors in denominators. So we have denominator 0 x equal 1 and x equal minus 1. Then we say x equal 1 and minus 1 vertical asymptotes. So here we have three different factors in denominator. Then denominator zeros x equal 1, x equal minus 2 and x equal 0. And here this has two different factors, but this is very important. So numerator we have factors and denominator we have factors. We have a common factor x minus 1. So if we cancel x minus 1 factor, then denominator we have only one factor. Then we have only one vertical asymptote. But that cancellation x equal 1 undefined. That is all on the function. Then here we need to factorize it. And you identify if you don't have any denominator zeros, then not contain vertical asymptote. Okay, let's write them. Consider here denominator x minus 1 equal to 0. Then you say x equal 1 vertical asymptote. Then here denominator 0 x minus 1 x plus 1 equals 0. So x equal 1 x equal minus 1, we say vertical asymptote. Then when you consider this, take denominator x minus 1 x plus 2 x 0. Now you solve it. Then here x equal 1, x equal minus 2 and x equal 0. We have three solutions. Then we have three denominator zeros. Then you take this. Then you factorize the numerator x minus 1 x plus 1. Here x minus 1 and x plus 2. So here we have a common factor. You cancel it. But when you cancel a common factor, you say x not equal to 1. X not equal to 1. So that is a whole. That is all on the function. So anyway, here take now denominator x plus 2, 0, x equal minus 2. Here the vertical asymptote. This is not vertical asymptote. So when you consider this relation, so we have factors x, here 4, here 1, here minus, and here plus. Now we have denominator zeros. Take denominator x minus 4, x plus 1, 0, x equals 4, x equals minus 1. Those are denominator zeros. Then those vertical asymptotes we obtain by denominator zeros. Those are imaginary lines, vertical imaginary line on a function. So denominator zeros are undefined for function. That's why vertical asymptote very important when you are doing mathematics. Thank you for watching us. This is MathDOC.